Alright, question 1. Triangle ABC and triangle BEF are shown with the measure of angle A equaling 35 degrees. Measure of angle B is equal to 119.1 degrees. Measure of angle C equals 25.9 degrees. Measure of angle D equals 35 degrees. Measure of angle E equals 119.1 degrees. Measure of angle F equals 25.9 degrees. Distance of AB equals 6. BC is approximately 7.9. The distance of AC is equal to 12. The distance of DE equals 9. The distance of EF is approximately 11.8, and the distance of DF equals 18. Note that the lengths of segment BC and segment EF are rounded. Is triangle ABC similar to triangle BEF? Okay, if I wasn't sure on what similarity was, I'd click on the key terms. And I'd go for similar triangles. Two triangles in which corresponding angles are congruent and corresponding side lengths are proportional. So there's two things that we have that are set out in this definition to check. Is similar triangles have one, congruent corresponding angles, and two, proportional corresponding sides. Alright, so that's two things to check. So the easiest thing to do is to check the angles and make sure that they are all congruent. So again, triangle ABC is listed out to triangle DEF. So that means triangle angle A, since it's, or vertex A is listed first, it's going to correspond to vertex D. So vertex A is right here. That angle A is 35 degrees, and angle D is 35 degrees. So far, so good. Second vertex B, second vertex E. Those are corresponding vertexes. Angle B is 119.1 degrees. Angle E is 119.1 degrees. Yes, those ones so far match up. And last one is vertex C and vertex F. So that means angle C and angle F are corresponding. So angle C is 25.9 and angle F is 25.9. So we've met that side, that's requirement so far. The next thing to check is that the corresponding side lengths are going to be proportional. So the corresponding side lengths will be between corresponding vertexes. So the first two are AB. Corresponding side length would be between the first two, which is DE. So AB is corresponding to DE. And then we have the next one. So second and third. Those would be corresponding. So B to C and E to F. And then we have the last one, first to third. So we have A to C and D to F to be corresponding. So now how we check that is we check the distance of AB times the scale factor has to equal the distance of DF. And then we're going to check that the scale factor is the same for every single one. So that means that the distance of BC times the same scale factor has to equal the distance of EF, because those are corresponding sides, and then the distance of AC times the scale factor has to equal the distance of DF, because they're corresponding sides. Oh, I listed this out twice. This one is DE, not DF, for corresponding side length. So AB is corresponding side length is DE. I apologize for that. So let's use substitution. AB is 6, DE is 9. So I'm thinking to myself, do I easily know a number that 6 times this number would equal 9? I do not easily know that number, so I'm going to go over to our symbol lab and type in 6 times S equals 9. Remember, the goal of this is to focus on the relationships, and if the algebra of it is a struggle, this will help you. So here's the steps. We're going to first divide both sides by 6. So 6 divided by 6 reduces down to a 1. So that's where that goes. And again, remember that that's implied. 9 divided by 6 is 3/2. So now we're going to go through here. That means that S is equal to 3/2. So when we come back in here, we're going to check that S still equals 3/2 to make this true. So the distance of BC is approximately 7.9. Let's see if multiplying it by 3/2 gives us approximately 11.8. We want to check that. This is what we want to verify. So I'm going to go over to the symbol lab again. Remember, it was 7.9 times 3/2. And we're looking for 11.8. So it's about 11.8. So that one's checking out. So yes, that one worked. Now the last one to check is AC. AC is the distance of 12. We're going to check that if we multiply it by 3/2, that it's going to give us a distance of 18, because that's the distance of DF. So again, I'm going to type in 12 times 3/2, and this is going to give us 18 if it is proportional. Okay, so it gives us that it is 18. So that means, yes, again, S was equal to 3/2. That means that all of the corresponding sides are proportional because our scale factor in each of these was 3/2. So yes, these two triangles are similar.